Hello Math 1680 students. I'm making this video in response to some students' request, and the request is about some in-depth covering on exercise set number 7. Now this is just before the exam, so I better not go too in-depth even though that was the student's request, because if I do that, I'm going to run a lot of students astray outside the exam range. I'm not going to do that. So I'll concentrate upon the topics that are kind of aligned with exam level topic. And consequently, I'm going to end up with repeating exactly the same thing I talked about already twice. Once in main lessons and the second in exam review. Well, here we go anyway. It's pretty much the same as before, but here we go anyway. Okay, here's the problem, and this problem is about normal distribution. The problem explicitly said normally distributed. And the mean is 62 and the standard deviation is 4.95. Problem 1 is about proportion or probability, and problem 2 is about percentile. One is forward and the other is backward problem. I don't want to exhaust these required problems, so let's go to exactly the same problem in different setting, different numbers. It's exactly the same. Okay, here we go. According to Center for Disease and Control and Prevention, the mean height of 18-month-old American girls is about 80.2 centimeters, and the standard deviation is about 2.70 centimeters. So previously we had mean of 62 and standard deviation of 4.95. Here we have mean of 80.2 and the standard deviation of 2.70. So these two problems are exactly the same. You see, numbers are different, otherwise exactly the same. Do not pay attention to speeding cars or height of girls. They are not important in terms of mathematics. The numbers here are 80.2 and 2.70. Here, 62 and 4.95. What's the difference? Nothing, absolutely nothing. Okay, let's go. Based upon the information, estimate the percentage of 18-month-old American girls whose height is less than 75 centimeters. Okay, all right. This is normal problem, so always you begin from a picture. If you don't draw the picture, you're not going to get credit. Here's a process. Outline, center, end, and then shade. Outline will be provided. Well, even if I don't provide, you can draw some kind of outlines, kind of like this, going up and down. It doesn't have to be really pretty. Anything will do. Now, center. Use your common sense. What's the center? Of course, the mean is a center. Okay, all right. Now, end. Okay, where is the other number here? 75 centimeters. Where does it go? 80.2 is over here. 75 is less than that, so it should be left-hand side. Exactly where, how much here or on here, it's hard to tell. So you just use your own discretion. It doesn't have to be really accurate. Okay, let's go to step 4, shade. Shade here to the left or shade here to the right. The problem said less than. In mathematics, less is left, big is right. Less is left, more is right. So shade left and that's it. This is the most important step. Next, we're going to use some formula, and that formula is end minus center over SD. So z-score is end minus center over standard deviation. Later, this will be changed into SE, but that's after break. That's going to be the second half of the course. And this is formula number 1 of this course in terms of the level of importance. Okay, in this particular case, what is it? What is n? 75. Minus 80.2 and minus center over standard deviation is 2.70. And that's your z-score that you'll have to calculate. And I'm getting about negative 1.9 something. And we're going to take 2 decimal digits. Negative 1.93. And why am I taking 2 decimal digits? That's because I have to look up the normal table, which will be provided to you for the exam. And that normal table uses up to the 2nd decimal digit. How to use it? I'm going to waste time here because that's something I explained already extensively in the main lesson. So let's just go ahead and do that. Negative 1.93, okay. Negative 1.9, where is it? Negative 1.9 is here in this row. So I have to use this row. And negative 1.96. Negative 1.93, excuse me. Negative 1.93, so it's here. Negative 1.9 and then 3. So 0.268, that's the probability. I forgot already. 0.0268. 0.0268. And look at the picture. Does it look like about 2.68%? Looks like it. Here's the complete answer. And okay, here we go. Let's repeat this. Based upon the above information, estimate the percentage of the 18-month American girls whose height is less than 82 centimeters. Can you do this? Copy and pasting. First step is always drawing a picture, and this picture is of course previous picture. I just copied and pasted. This time I want 82 centimeters. That's the end. So outline and center, okay. Where do we have 82 centimeters? 82 is bigger than 80.02, so end must go to the right. And then you have to shade accordingly. 75 is less than 80.2, so went left. But 82 is bigger, so I have to go to the right. So 82, okay. So this is a situation. Again, the problem is about less than, so we have left-hand side shading. If you have more than, the shading should be in the right-hand side. Well, in this problem, I'm using less than again, so all right, less than 82 centimeters. And then let's do the z-score computation as before. What is z? Z is equal to end minus center over SD. So this is approximately equal to end 82 minus center over SD. 82 is the new end, and then center 80.2, standard deviation 2.7, those are all there. So calculate all this, what do you get? 0.67 approximately speaking. Okay, I need 2 decimal digits for the z-score computation, and let's go to that PDF document again. And 0.67, and all these are negative. 0.6, okay, it's in this row. 0.67, okay, what do I get? 0.7486. 0.7486. .7486. Okay, that's it. Look at the picture. Does it look like about 74.86 or 75%? Does it look like that way? Well, indeed, right here is half, so this is 50%, and then I'll be more. So yes, it does look like about 75%. So it looks okay to me. So in the previous problem here, this should be changed accordingly. So this is 82.0, that, okay, and then this should be positive 0.67 approximately speaking, and then there's 0.67, and then I just look up this z table, normal table. There you go, there's the answer.